Hello, folks. I hope I'm on. It says that I'm on, but I don't see myself. So I would think that if you have any message for me, let me know if you can hear me, if you can see me. Sound is okay. Thank you. How about me? Can you see me? Okay. I rebooted my computer. I'm using a different computer. That's the issue. And I'm not familiar with some of these things in YouTube. I do the best I can here. Okay, so let's get started. I'm going to be talking a little bit about ether. Someone asked questions about or had some issues with ether. I'm going to talk a little bit about shape. There were some questions about shape and about field and about ray. And then I'll get into consciousness. But let us start with our extinction segment, some issues there as well. First of all, I can say regarding the Ukraine war, which is a big issue, but it's falling kind of like low in the news. And you have both sides say they're winning the war. As always, all the military always ace, on each side say, we're doing just great, the 60s and 70-year-old people make the war, and the 20 and the 30-year-olds fight it and die for it. Would you die for Al Capone? Well, these people say that they're dying for the country, which is more or less the same thing. Anyway, so there's not much going on there. We're waiting for them to reach some kind of agreement, some kind of treaty. And all those people who died, well, nobody will remember them, for sure. In fact, all I can say to you is the following. Do you remember anyone who died in the Civil War or in World War I or the Napoleonic Wars? Well, of course not. Nobody remembers them. And even if you did, it doesn't do them any good. They're out. Okay, so much for that, but let me look at something else. There's this fellow I talked about a couple times now, because it's been on the news lately. His name is Avi Loeb. I'm not sure how to pronounce his last name. And he's a Harvard professor. And this is the issue. The issue is that if you're a Harvard professor, like in astrophysics, well, you got a big title. And so you have a lot of persuasion power, right? So people listen to them thinking that they're going to get some information that's valuable. And this fellow is into ETs. He's trying to push this this issue into the public, possibly to become famous, make some money, all of that, or all of the above, And this fellow, sometime back, a couple of years back, he was the guy involved with see if I can get it here, dropped on the other side. Give me a second here. Let me get it up there again. And he's the guy who came up with the umama, as I call it, the umama. A little stone, elongated stone, flat stone that came into our solar system, and he was one of the first to say that it came out of the solar system, maybe from another galaxy, and that maybe it was a piece of some artificial artifact, and that it kind of indicates that there are ETs out there that maybe are trying to even communicate with us. Okay, so this is one of the issues. That's how it started, but then I think it was a couple months back, they found some spherules. I think it was in the Pacific. I can't remember now exactly where. And this is what they think they are. One guy thinks it's a dino killer, the one, or something similar to the one, to an asteroid that killed the dinos, and that maybe it was artificial. Okay. And the important thing here is what that first line there, it says, it would be among the most extraordinary discoveries in scientific history. Fragments of an alien spacecraft from another solar system that landed on Earth. And, well, it would be an extraordinary discovery, but science is not about discovering America. like Columbus did. Science is about explaining. You have to explain something. Otherwise, you're not a scientist. These people confuse discovering and simply describing for science, and that ain't so. And so it says, analysis of the spherules composition proves they came from where? Beyond the solar system, okay? So some rocks that came from outside the solar system. But he takes it one step further and suggests, insinuates that these spherules are actually artificial, okay? And I guess you know what that means. It means ETs, some people are trying to communicate with us or sent them over for who knows what reason. And says some scientists around the world have treated his claim that he found alien artifact with a lot of skepticism, okay? And so, he's trying to push this at all costs. Anything he finds out there, he immediately identifies as ET and intelligent life and someone trying to communicate with us. He's into that. And he's a professor of Harvard. And that's why it's a little dangerous because of all the influence that he has, all the power he has simply by his authority. Another reason why you should reject authority in science. No such thing as authority, and no such thing as description or discovery. Okay, we don't discover anything in science. In science, we explain. Okay, and that's where the problem starts. Okay, and so this is some of the opinions that people had about him. These are some astrophysicists, pulled out 4 of them out of an article. And so they all believe that, or some of them believe that, they could be outside of the solar system. Others believe it could be artificial. They all give that possibility. And some say, like Martin Rees there says, he doesn't agree with that at all. He doesn't think it's, artificial. Okay, he questions that. He realizes what Loeb's trying to do. He's just trying to get this pet peeve, into the public eye so that he can become famous and make money and who knows what. Okay, and you can see some of the comments there. One fellow says, and all these are astrophysicists, by the way. First one there, Phil Sutton says, I don't think you can rule out that it could be an alien spacecraft. Or an object similar to what wiped out the dinosaurs, hit a planet in another star system, sent some material out. What if another civilization found us before we found them and sent probes out? And you wonder, these people are scientists, and they have these ideas about, how the universe works and what's out there. So these people are totally lost. Another one, Monica Grady, says, Love's work is not sufficiently convincing to say the metal particles definitely from a meteorite, let alone an alien spaceship. Could be from a supernova or exploding star. And could have been made on Earth as a side effect of nuclear weapons testing, because it was found near a nuclear site, okay, or where they do some atomic work, And another one says it is credible that they have a unique extrasolar composition. The discovery has merit scientifically, does it? But is being cheapened and undermined by claims of alien technology. Well, the problem with all these comments is that they have nothing at all to do with science. That's the problem with it. Science is about explaining, not about discovering. Even if we discovered an alien spaceship landing on top of the White House, it would not have anything to do with science. Okay? Or you can say the scientific part would be, if anything, explaining something about it, about that event. But if you just say, look, we discovered America, we discovered a chair, I discovered the wall, I bumped into it, that's not science. Okay, so we have to keep in mind what science is, and these people have the wrong notion of science. So let's look at this. What is a scientific method? What is it about, and how does it compare to what these people do? Well, what scientific method is not is evidence, proof, persuade, and convince, which is what all these people are trying to do. They're saying, look, I'm going to convince you that this thing came outside the solar system, okay, and that it's a some will say, well, yeah, it's just a rock, and the others will say it's artificial. But other than that, they're all anyways in the wrong boat. They're all talking about evidence, proof, and persuasion, convincing people. That's got absolutely nothing to do with science. Then you have here the real scientific method, and it's assumption. You make an assumption to understand the theory. You make an assumption, you say, let us assume God exists. That's an assumption. Okay, and then you explain your theory. You say, this is how God created the universe. Okay, no problem. Then it's consistent. You have an assumption, you make an assumption that God exists, and everybody should understand that, is an object with location, and then you proceed with your theory and say, this is how God made the universe. He put it in his assembly line, built this, and that, no problem. He explained how the universe was made according to his way of thinking, this presenter, okay? And these people don't do that. They say, let me convince you. Let me convince you that this came out of the solar system. Let me convince you, let me persuade and recruit you to my way of thinking that this was created by artificial intelligence, okay? So no, we have the wrong scientific method in the minds of all these people, and this is what they pass on to the next generation, from generation to generation. Okay, so this is the problem. Okay, so here's the mathematical method, and this is how this Avi Loeb this is what he's trying to do. Okay, you can see it here. Okay, here's the mathematical method. You see a bee flying around a flower. You conclude that such symbiotic perfection could only be accomplished by an intelligent designer. This proves that God exists. Straightforward. Okay, this is what he's trying to do. He's saying, look, I saw the bee flying around a flower. What else could it be if not God? Okay? Who created this perfection? And likewise, this Lev is doing the same thing. He's trying to persuade the crowd that his careful studies prove that the spherules came out of another galaxy. But having established his first proof, right, his initial proof, he moves on to another proof. He attempts to persuade the throng that spherules are artificial, meaning that some intelligent ETs made it. So he went from evidence to proof and then used that as further evidence or as an assumption for a further proof. So he's just doing proof and evidence. That's all he's doing. He's doing persuasion and convincing. At no point did he do any science. Okay, he's just giving us his opinion, and he's trying to shove it down your throat. That's what they consider science. Okay, and this is the real problem. The problem is the notion that these people have of science and the one that they spread in the universities to the new generations, and they've been doing this for decades now. Okay. Okay, to top it off, since this subject is so popular, turns out that there were some issues where Congress held a hearing on ETs, especially on, unidentified flying objects, and they wanted to get to the bottom of it. As a result, apparently someone gave the order, and this is what they've done. The Pentagon releases a new website where they're going to put all the UFOs, the photographs and whatever they have on unidentified flying objects that they've collected over the years. Okay, so you can go to that site and see that. And I think what's going to happen here is that, people are still going to have doubts. They're going to say, well, you didn't put everything out there. You just put the stuff to convince us that you know nothing about extraterrestrial aliens. And this is the problem. You'll never be able to convince those people because the person who's got it in his mind that ETs are here and that they built the pyramids and who knows what else, you're never going to convince them. They're just going to insist that, oh, you're hiding something and, there's no hoax regarding ETs. It's, the crop circles and all this stuff. All that's real. It's done by ETs. And the government knows it, but they don't want to tell us. And now they put this site, and they're just trying to convince us with this fake evidence or little evidence that they have. They just put it out there to please the crowds. But the real evidence, they're hiding it over there, in Washington, very closely guarded. Okay, so this is how these people think, and I don't think you're going to ever be able to convince them. Okay, that's my thought on that. Just in case, like if you missed something here, you have the Exeter UFO Festival. Turns out there was an incident at Exeter. I don't even know where this is, somewhere, I think Connecticut or Massachusetts, somewhere up there, I didn't check. Anyways, they have this celebration because there was a sighting in 1965. And there you can see the newspaper, what they were talking about, you know, how it became news in those days. And they said they saw a red light flying object. Great, red lighted flying object. And because of this, you know, now they have this festival, and you have even people speaking, so-called experts, says to talk Bigfoot, UFOs, and preparing life preparing for life with ETs. Okay, so as you can see, you know, all these people are a lot of people are into this, and some people are making big money on this, or at least they try to, talking about stuff like this, like, you know, Bigfoot and ETs, and, you know, that man didn't go to the moon, and that the earth is flat, and who knows what else. And a lot of, it's a cottage industry with all these people who, you know, essentially, you know, disagree with the government, or believe that the government is hiding something, and they have all these shadows that are following them, you know. I don't know how they sleep at night. Okay, and just in case, you know, that followed up, Exeter came after this, Roswell, that most people are more familiar with, and that's happened in 1947. This came out of the Wikipedia. It says that recovery of metallic rubber debris from a military balloon by Roswell Army Airfield, and the press release announcing possession of a flying disc. Decades later, conspiracy theories claim that debris from the alien spaceship had been covered up by the government. In response, in 1994, the U.S. Air Force published a report concluding the crashed object was a top-secret nuclear test surveillance balloon from Project Mogul. Okay, great. So people won't believe that, and they'll say, no, it was a flying saucer. It came from outer space. You know, so it makes you wonder about all these people. There's no way you're ever going to convince them. He who wants to believe just believes without any reason. They don't even try to explain it. They just believe it. Okay, and so what can I give you as my conclusions? Okay, regarding all these ETs. I've said a couple times these conclusions, but here I summarize them. Humans have the highest level of intelligence that Father Universe can conceive or grant or concede. There is no higher intelligence in the entire universe than what we have in our brains. And I don't know what kind of intelligence people expect, those who believe in super intelligence. Maybe their mothers did not give them enough intelligence, and they're complaining about that. But no, Mother Nature has ran out of gifts to give us. We are the highest intelligence possible in the universe. It'll never get better than humans anywhere in the universe, anywhere in time. Okay? If there's human level intelligence somewhere in the universe, it looks like us. Okay? I like to say that intelligence of our level, right, descends from the trees. Okay? You will not see lions that are intelligent as us. You will not see fish. You will not see birds. Okay? It's got to be something like us. It's got to be a monkey. It can't be anything else. It's got to be a four-legged, bipedal monkey. It can't be a four-legged, you know, quadrupedal. Okay? Humans cannot travel to another star and never will. There's no way we can make it to the nearest star, let alone to, I don't even think we'll ever make it to Pluto or places like that. We might, if time allows, make it to Mars. I even doubt that, but it could happen. You know, that's a possibility. I think we can send probes to Mars, unmanned probes. We can probably send robots there. But another thing is to send a human. You know, you got to train a lot, you got to study a lot, you know, gravity and time away from base, and so there's a lot of issues to be dealt with, you know, when you're sending someone as far away as Mars, and that's the nearest planet almost. You know, I think it's the second nearest planet after Venus. So you know, we're never going to go to another star. We might make it to Mars at best. The chances of human spacecraft reaching a human-level civilization are next to nil. And I'm not talking about manned spacecraft. That's impossible. But we can send a spacecraft like you got the two Pioneers, 10 and 11, going out of the solar system. What are their chances of ever being spotted by another civilization? And my answer is none. And I'm being kind or unkind. Really, I should say next to none. So I'm not so absolute, but I think it's closer to none than to next to none. Okay, that's my honest opinion there. Okay, why? Distance is forbidding. Okay, the distances are impossible. That's one issue. But even worse is time. Time is staggered for different civilizations. And so when we live, last 200 years, that's when we had electronics, when we developed electronics. Let's concede the full 200 years, even though that's not true either. We didn't really have sophisticated devices until the 20th century, so we can just say that's been 100 years. But let's concede 200 years. 200 years is a drop of water, even less than a drop of water in the ocean of the universe, in both space, really, on the one hand, but in time, in terms of time. And so here you have 200 years, then we go extinct, okay, because we're about to become extinct. And this is going to happen to any civilization like us, any humans like us that live elsewhere, which is already quite scarce. And for our spaceship to reach their neighborhood, one, not crash against anything by the time they get there, and to hit it in those 200 years in which they have developed their technology to be able to spot these things, the chances are zip. So we shouldn't send them out to talk to someone. Besides, we'll never figure it. We'll never find out whether someone really saw it anyways. But I don't think that'll ever happen anyways, that the probe arrives at another place that is seen by another group of human civilization with intelligence to spot it, and then it happens to land, in someone's backyard or whatever. What are the chances of all that? It's zip. It's absolutely zip. More than likely, those probes are going to crash against something somewhere, fall into some sun, some star, and that'll be the end of it. So, no, and now let's look at it in reverse. Someone sent something out from, some other planet. Well, the first thing is they would have to more or less live around the same time as us. In other words, by the time the probe gets to us, their spaceship gets to us, they're gone. But it should arrive, by the time we live in those 200 years, and that we developed electromagnetic technology. And the issue is, what are the chances of that? How many probes are there going out there coming in our direction? And again, my answer is none. Okay, let's move on to another subject. A fellow talked about the ether, and I do want to make sure that we dot all the I's and cross all the T's, or cross all the I's and dot all the T's, whichever one, right? And so what do we say? Well, we say the ether is a bunch of particles. That's what I've told him. And he did not like that. And no etherist likes that. In fact, all the people who vouch for the ether never figured out what the ether is, okay? And so the question is, where does the word ether come from, And so this is what the fellow said. He said, ether cannot be a bunch of particles, okay? And this is more or less what all the etherists that have come here to debate say the same exact thing. They say, it ain't what you're saying, Bill. Okay, it ain't particles. I know it's particles, it's always been particles, but these people have another notion of what the ether is. And so you try to pull their tongue, pull their brain, whichever one, to try to find out what do they have going through their minds. What are they thinking about when someone mentions the word ether? What's going through their minds? So the fellow first says, no, it's not a bunch of particles. Okay, great. The reason why the ether cannot be made of particles is very simple. What's the stuff between the atoms, keeping a bunch of atoms together to form an object? Aha. And he answered his own question there, why the ether can't be. Yeah, the ether can't be because of that. Because, you have to have something between any two particles. And if you don't have something there, how do they interact? Especially pull, entanglement, gravity, any pull. Even if we conceded, gluons pulling two quarks together, it's always pull. And the only force that no ether is on planet Earth ever was able to answer is the force of pull. And this is where they fail. They cannot answer the force of pull. No one can produce a pull unless they put something between two objects. Period. There's no possibility. And so they all try to pull. They all try to produce pull through push. Casimir type or Lesage type mechanisms where you remove what's between two particles and the ones on the outside push them towards each other. That's the notion of pull. But they cannot produce pull because for that you need an elongated object that somehow physically binds any two particles. And of course, since they can't see or touch anything there, they said there's nothing there, and so they're going to do it through push. Push is the only mechanism they ever were able to explain. They have never been able to explain pull. And so he says a magnetic field cannot be made of discrete particles. Absolutely. You're totally right there. And I'm on your side there. Again, you can't have gaps. Same for gravity. If you have gaps, then magic is responsible for the interaction. Absolutely. Simple as that. Totally in agreement. That's why the ether can't be, because ether is a bunch of particles. But this fellow has a different notion of what the ether is, and this is more or less, I guess, where it comes from. Let me get rid of this one here. And it's what good old well, I got the wrong one out. Anyways, it's what the Greeks thought of the ether, and it was that in the old days, in the days of the Greeks, they thought the ether was air. Ether means air. Is another word for air. It's just the air of the gods. And what do you think they thought of the air? Well, they thought of the air as particles. And even to this day, people think of air as particles. We call them atoms, we call them molecules. But what is air? Air is molecules. And the ether was just some other type of particles that we could not see or touch. But it was the motion of those particles, especially in a wavy motion, that they studied throughout the 19th century, thinking that a wave of light consisted of particles, of discrete particles, waving up and down, oscillating. That's what they all thought. What did you think the ether was when they talked about the waves of light? They thought the wave of light was made of particles. And they did it mathematically. They said it's a bunch of vectors, electrofield, magnetic field. That's essentially what they concluded. But what do you think they had in mind? Why do you think what do you think Michelson and Morley were testing? Well, they were testing to see if there were particles, gazillions of particles, and they wanted to see if the Earth was going against that ocean of particles, and if there was a difference in the speed of light, etc. Okay, so they always thought of particles. And these people say, no, it's not particles, Bill. Okay. So here we have space. Okay. Okay. Very dark. Very nothingness. Okay. So we call that space. And now we're going to put some ether in there. Okay. It looks like this. Okay. And that's the ether, a bunch of particles. That's what they always thought. Okay. That's the way they always pictured it. Okay. Okay, so here we have the universe, okay, and pretty static because, so far away we don't really see things moving. They're so far away that we really see everything kind of static out there, the firmament, as it used to be called. And here it is, the universe with particles, okay, with these ether particles. And everything is made out of these particles, not only the objects such as the galaxies and stars and so on, but also the space in between them. Everything is particles. That's the way everybody's always seen this. Nothing has changed in the last 10,000 years. Even those people who say the ether is not particles, what do you think they propose? Well, they don't even realize they're proposing particles. And in fact, it happened to this fellow. He says the following. He says, this is what he proposes. He says, I'm saying the ether is a continuous fluid. And I already told him that, a fluid is made of particles. because that's what fluid is. It's a substance that is made, in fact, he put the definition there, a substance, right, such as a liquid or gas that can flow. Okay, but what is he saying? It's a liquid or a gas. What is a liquid or a gas made of? Atoms, made out of discrete particles. That's why it can flow. So if you're going to use the word fluid, you got to relate it to how the word fluid is defined. Otherwise, you got to define the word fluid in a different way. Okay, substance that easily changes its shape. Yeah, he hasn't said anything. Capable of flowing, changing, readily shifting, not rigid. So you can't say that ether is a fluid because the word fluid is a verb, not a noun. Okay, so you can't say ether is a fluid, right? Fluid is what ether does, if anything. Okay, so you haven't told us what the ether is. You're just telling it what it does. It flows. That's all you're saying. And with that, you haven't told us anything because we still don't know what the ether is. You have to point to the ether first, static, before it moves. Then you can make it flow and fluid and whatever you want. But first, you got to point to it, in a static mode. You don't point to a running lion or a galloping horse. You point to the horse and say, horse. And now I'm going to make the horse gallop, and that's going to be a galloping horse. And now you see the horse galloping. So we can understand, we can follow your train of thought. First you point to the ether, then you have the ether flow or be fluid or whatever. Yes, a fluid often refers to liquids and gases. Yeah, in fact, it does only refer to that. Okay, so are you saying the ether is a liquid or a gas made out of atoms? And if it's not made out of atom, well, you got a lot to explain. Okay, you can't just say it's a fluid. At least those are the ones we know the most. Yeah, it's the only ones we know. You can also say that, when you ionize gas, it becomes plasma, but plasma is not an object. Plasma is moving gas. Okay, you've got something moving. It's called ionization. Okay, so something is happening. Happening is a verb. Okay, so plasma includes the object and the motion. You can't get rid of the motion from plasma. But there's absolutely, it's like, the word, the dead cat, no such thing in science, in physics. Physics, there's only a cat. Dead is what he does, and alive is what he does. But the object is called cat, only cat. No dead cat, no brown cat, no yellow cat, no jumping cat, just cat. Yes, a fluid often refers to liquid, okay, but there is absolutely no reason why the ether can't be a fluid. Well, yeah, okay, so it's a fluid. All you told us is what the ether does. You haven't told us what it is, but you're saying it can't be, meaning what it is. So you don't understand. You don't understand that fluid is a verb, not a noun. Fluid is a category of things that flow. Okay, it could be gases, could be liquids. So when you say ether is some kind of fluid, you just put it under a category of things that flow. And still you haven't told us what the ether is. You haven't pointed to the ether. That's why we need a picture. If you absolutely insist, I'll draw you a blob of ether. Okay, and then you see, like, you can point to water, you can point to oil, you can point to molasses, right? You can point to all these fluids, right? All these liquids, right? But at least I can point and say, okay, I know what molasses is. It looks like that. Oil is that. Water is that. Okay. The fact that they're fluid, it doesn't mean that you've shown what it is yet. I mean, are you saying that ether is molasses? Why not? I mean, so far you haven't pointed to it, so I'll point for you. I'll say, you're saying that ether is molasses. And if you say no, you haven't. You gotta. The onus is on you to tell me what it is in the alternative if it's not molasses. Okay, so that's the way it works in science. You have to tell the crowd. Don't expect the crowd to tell you what the ether is, because I'm going to tell you what the ether is. A bunch of particles. That's what it is. What it's always been. You don't like it, then you got to put something there for us to see and say, look, this is the ether. If you think ether is an object, and he says it's a blob. Okay. Okay. But here is the some of the problems with what he's saying. He's saying it's a continuous fluid. Continuous in physics means made of a single piece. Okay, that's what continuous means. And it's the opposite of what the Greeks thought of continuous. Aristotle very clearly states that continuous means that you can break it into pieces. It's made of parts. So it's the opposite of what continuous is in physics, which is made of a single piece, not made of parts. That's what continuous means. So the ether, this fellow says, is made of a single piece, and it's fluid. So I don't know what he's talking about. Is he talking about rubber, or what is it, you know? How can it be made of a single piece and be fluid? And yet this is how we look at the single thread in under the rope model. It's continuous and it's fluid. In fact, the single thread contains all the properties of solids, gases, and liquids. And in fact, that's why we have solids, gases, and liquids, because the single thread contains all these properties within it. Okay? It has that ability. But fluid is a noun plus a verb. Okay? You can't have something called fluid. There's no physical object, standalone object called fluid. Okay? Fluid is a noun that does something, verb. So fluid is not a thing, a substance or an object. Fluid is what a thing does. Okay? It's a verb. It's just like plasma. Plasma is a noun plus a verb. Okay? Plasma does not, you can't point to plasma. And people say, oh, I pointed to plasma ball and a plasma in it. No, what you're pointing to is a verb. Something is happening inside the plasma ball. If it's standing still, it's called gas, not plasma. For it to be plasma, it's got to be moving. It's got to be ionizing. That's what plasma is, ionized gas. Without that ionized, it's not plasma. It's called gas. Okay, and I don't know if you understood that. Wind, again, another. Wind is not a thing, not a physical object. Okay, wind, it already involves or invokes or embodies motion. It's moving air. Okay, field, same thing. Any kind of field you want. You want gravitational field or magnetic field, no problem. Electric field. It's the difference between forest and many trees. Okay. Okay, forest and many trees are the same, but you're treating field as if it were one tree, or if the forest were a single object, and that's not the case. Field is like a forest, and it means many values. That's what it is. And likewise, the ether means many corpuscles. That's what the ether always has meant. But apparently this fellow thinks it's a blob. Okay, so what do? Well, since he hasn't done it, I'm going to do it for him. Okay, we're going to make ether a blob, just like he said. We're going to try to follow what he described. Okay, that's all I can do. Okay, so here it is. I showed this last time. We have the astronaut, and he releases a blob of some kind of liquid, some kind of fluid in space. You can call it water if you want, even though it's kind of greenish, but we'll call it water. No problem. Okay, so we got that. And here we have the blob up front so we can see it much better, okay? And there you see it, okay? And what's the issue? The issue is with this, now you have to explain light and gravity with that blob, okay? And so here's what you got to explain. Here's light, okay? You got to explain waves of light inside the ether, if that's what you think light is. Otherwise, you got to explain light in some kind of way. And all I can do is put what people always have thought, that light is the vibration of the ether, and that's what I'm showing there. If you don't agree with that, no problem. You have to tell us what you think light is in your blob, or under your blob, or outside your blob, or whatever. Aside from the fact you got to tell us what the black stuff is that gives shape to your blob, because if you're going to talk about a blob, there's something outside of it, and you have to identify that blob. In other words, that black stuff. In other words, what you got to tell us is if the blob has shape, and hopefully it does. If you're going to talk about a blob, then you got to tell us what it's what is within it. In other words, the black stuff, is that space? Is the blob contained within space? And what is space then? You know, because a lot of people identify the ether with space. In other words, a lot of people think that space and ether are synonyms. There is no such thing as ether and space. They're both the same thing. Other people think that ether is within space. Okay, and that's fine, but then you got to tell us what space is. Okay, you can't just say it's within space, because we don't know what space is yet in your theory, in your hypothesis, in your way of thinking. Okay. Okay, so here let's put the blob. Let's freeze it. Okay, there you have it, frozen blob. Okay, In fact, we'll go a step further and we'll put it on white so that we can see it really well, okay? And again, those who propose a blob have to tell us what the white stuff is, in this case, right? No problem, but you got to identify every object in our field of view. You got to tell us what the white stuff is if the blob is ether. Okay, so far so good. I hope you can follow along. I'm going to try to be as slowly as possible so that everybody can follow along, okay? Okay, so we got to explain gravity well, you have to explain light, that's one issue, but now we have to explain gravity. And I'm going to put a scenario, okay? Here we have a little spoon that falls to the floor, okay? If you don't believe spoons fall to the floor, go to your home, go to your kitchen, take a spoon, let go of it, and you'll find out under normal conditions, it'll fall to the floor. We call that process, whatever is doing all that whole thing, we call that whole phenomenon, we call it gravity. Okay? Okay, so now what we're going to do, we're going to freeze the spoon in midair. Okay? So far so good. It's going to fall down, but we just froze one frame so that we can explain the following. We're going to go in there now, and we're going to use the blob. Okay? Is the blob pushing on the spoon? That's one of the things, one of the possibilities. Okay? If you think the blob is pushing on the spoon, you got to tell us why and how it does it. You know, what the cause is. You know, why does the blob go downwards instead of upwards, for example? You know, if this is the way you visualize it, okay? Again, I'm not putting words in anybody's mouth. I'm just saying this is one of the scenarios you got to explain if you think ether is a blob, okay? Here's another one, okay? This time it's below because the blob is going to pull on the spoon. You got to explain to the crowd how it is that the that the blob pulls on the spoon. Why does it pull? Why is it going downwards? Why doesn't it go upward? Why doesn't it push from the bottom upwards, for example? You know, and all these things you gotta really analyze that to death. Okay, if that's what you think, the ether is a little blob that's pulling or pushing. Okay. Now the important thing here that I want you to focus on, because I'm sure he's going to reject these two scenarios, right? And a lot of the etherists will as well. They're saying, Bill, you're treating the little blob. That's not our ether. Our ether is the entire universe. In other words, the ether covers all of space, the whole universe, or whatever, right? Okay. The reason I put these two scenarios down and showed them here, illustrated them, is because I don't want them to say that there's a portion of the ether that pushes or pulls the spoon down. In other words, we'll call this the little blob. Okay, we'll call it the little blob. The little blob either pushes or pulls on the spoon upwards or downwards. Okay, we'll call that the little blob. Now let's go with the big blob, which is what these people usually think of when they say ether. Okay, here's the big blob. Okay, now, here we have the earth. We have the spoon falling to earth. And you can see the blob, I have expanded it greatly. And we will assume that the blob that covers the entire earth, it stretches all the way to the ends of, all the way to hell. Okay, so now we have the little spoon falling. And again, if ether is the entire ocean, the entire blob that covers the entire universe, you have to explain how this blob moves the spoon downwards in one region of the universe. In this case, space. In this case, your home, your floor, your house, right? So you got to explain how the whole ocean does this. And just in case, here's the one coming from below as well. Remember, you're in the North Pole, and the other guy's in the South Pole. And so your spoon is falling towards the center of the earth. This spoon is falling towards the center of the earth. So it's going in the opposite direction as yours. And you got to explain how your blob does this. And again, we're asking you to explain how the entire ocean does this, okay? You cannot select a little piece of the ocean and say, look, my little ether here does this. No, you either talk about the ocean or you talk about water. You either talk about the forest or you talk about one tree. You either talk about children or you talk about child, or you talk about, people and you talk about man. You can't use the ether in both ways. You can't say the ether is the entire ocean and the ether also in this little region of the ether does this. Okay, I hope you understood the issue. The issue is you cannot use the ether as both forest and tree, okay, which is what these people usually try to do. They say, look, the ether is the entire ocean. It's this blob that fills all of space. Great. So ether is the entire ocean. Then don't tell me the ether over here pushed, you know, here we have a spoon, little spoon, and we're going to let go of it. And I say, how did that happen? You said, the ether did it. Well, the ether is the entire ocean. How did the entire ocean of the entire universe, filling all of space-time, all the way to the ends of the mind, right? How did it do that? Okay, and again, if it pushes it down here, how did it also push the spoon on the other side of the planet in the opposite direction? Okay, so you got to explain those two things, right? Okay, and here, let me give you another scenario similar to that. Here's a little fish, and we have that little fish in the ocean. And here you can see the blob is covering the entire Earth, so the Earth is inside the ether, inside the blob, right? And we have a little fish within one of the oceans, Pacific Ocean in this case, within the Earth, okay? So now we're going to look at the little fish inside the ocean. Here he is, okay? And he's falling towards the center of the Earth for some reason. Something is pulling the fish down. Maybe it's a whirlpool. Maybe something is sucking it downwards. The fish can't help. He falls, okay? So he can't avoid it. Here we see him a little more, blown up a little bit so that we can see the fish going down. Okay, and so the question is, the fish is going down. You cannot say the ocean did it, okay? In the best of cases, you can say the local water somehow, there was a current or something that pushed him down. But what is irrational is to say the ocean pushed the fish downwards, okay? Because you would have to explain that process, how the whole ocean, the whole Pacific Ocean pushed that little fishy down towards the center. We don't usually talk like that. We don't say that, the ocean pushed the fish down. You can say that a current did, or maybe there was some whirlpool that pulled on the fish. You can do that, but you got to talk about whirlpool and not about ocean. And the same way with ether. You cannot talk about the ether doing gravity if you're going to say that the ether is the entire ocean. Okay, because otherwise, if you're going to use the ether and the little blob, then you got to explain how the little blob pushes and how the little blob pulls. Now you got to go to that scenario. Then, I did not put words in your mouth. I'm just saying that if you're going to treat the blob as a portion of the blob, then we forget about the big blob, and you got to look at the little blob and how that little blob, pushes the spoon down or pulls it from below. Okay, so you either talk about the ether as the whole thing, the whole ocean, or you use some other word to refer to the little blob or the big or pushing or pulling. In other words, that's the homework. If you want to take it and want to resolve it. Those are the issues, those are the questions. I hope you understood them all. Otherwise, look at the video later on and figure it out what it was all about. Okay, let's move on to another issue that this same fellow, I think, raised, and it's got to do with this word ray. The only rays I know are these fish that are in the sea, that kind of ray, okay? But here it is. I think it's a fish. I don't even know if that's the case. Okay, so where did it go? Let me get this up here. Okay, so a fellow says, Young has never seen light. Talking about Young, what was his name? Thomas Young, who did the slit experiment. Okay, so he says he never saw light waves. Of course not. If he would have seen them, it'd be a cinch. If anybody would see waves, it'd be great. In fact, if you can see a wave, you can see a concept such as wave, boy, you've got good eyes. You got better eyes than God. It has never been more than an assumption. Exactly. And that's what it always is. It's called an assumption in science, in physics. So That's what a wave is. It's an assumption, not something to see or touch. It's an assumption. Good. Same for J.J. Thomson. He never saw electron particles. Okay? And he said the cathode ray tube experiment was freaking ray. Was a freaking ray? What do you mean a ray? What is a ray? You know, from one end of the tube to the other. And what do you think that ray was made of? Oh, I don't know. Tell us. Why didn't you tell us? And yeah, J.J. Thomson did not see a ray because, like good old Ray there, he was blind. He couldn't see it. That's why he couldn't see the ray. Okay, so we have to look up this definition of the word ray to find out what this poor fellow is talking about. Okay, and so here you have it. A ray is an idealized geometrical model of light or other electromagnetic radiation. So it's an idealized geometric object. That's what it is. So there is no such thing as a ray. It's just a way that these people try to talk, and they say, look, that's a ray. And what did you mean by a ray? Well, it means that there's something there. Okay, it's called a ray, and so yeah, it's just a geometric object. It's a straight line. That's all it is. And that's what it's always been used as. So you can't use the word ray because it's, first of all, it's a mathematical or geometrical object. It's not even an object. What it is an arrow that represents motion. You start at A and you move to infinity. That's all a ray is. So you can't use the word ray and say that light or electricity is a ray. Okay. So here we have the version from the rope model, okay? And here it is. What is light? That is on top of Ray Charles there. Well, light, every one of those rays, as you call them, we say it's a rope. Okay, in fact, it's not a single rope. You got gazillions of ropes there per ray. Okay, because the rope is such a thin object that we can't see an atom, much less a rope, which is much thinner than the radius of any atom. Much, much thinner. So you're talking about something that we can't see or touch for that matter. Just like we can't see the air, we can't see a rope. But that's what those light rays, beams are. You know, what we're staring at is the vibrations of the rope going from atom to atom. Okay, so what you're seeing there is atom to atom, and the ropes are striking one atom and being relayed to another atom all through the air. And that's why we can see all those, that light. Okay, what you're seeing is really the vibration of atoms. And electricity, well, electricity is at the bottom. Okay, you talked about a cathode ray tube, CRT. And that beam, that ray as you called it, well, that's a bunch of atoms. Actually, molecules, I like to use the atoms because they're easier to explain, but it's easier to understand it with atoms because you just put hydrogen atoms there and you merge them and you say, okay, let's assume all these hydrogen atoms are merged. Okay, and then what you have is counterclockwise and clockwise rotation of that whole string of merged electron shells. And that's what we say is electricity. Okay, so we do have an explanation for the CRT, the electricity or current running from one plate to another, and of a light, which is what you see on the top. And now the ball's in your court. You tell us what a ray is and what you think it's made of. And if you're going to put your blob in there, ether blob, no problem. Explain to us how the blob does light, how the blob does gravity. And again, like I explained a minute ago, you are supposed to put the scenario where you have this ocean and explain it with the ocean. And if you cannot explain it with the ocean, if you're going to go to the actual falling of the spoon, for example, then you have to talk about the little blob, which is the first two scenarios I showed, where one pushes, the other one pulls, and explain that. So you decide which one you want to go with. Okay, ball's in your court. Okay, another fellow raised another issue, and this has to do with the word shape. And the word shape comes from our definition of the word object, which is that which has shape. Very simple. That was the scientific definition that everybody missed in the last 10,000 years. No textbook of physics has that definition. No textbook of physics starts with a definition of object, although you cannot do physics without an object. Okay, so that's the context. Okay, so this fellow says the following. He says, get him up here. Saying object is that which has shape is absolutely absurd. Okay, good. Object. What is an object? An identifiable collection of matter. And he got that from the Wikipedia. It says a physical object or physical body is a collection of matter, visible or tangible surface. That's what they're suggesting it is. That's the notion these people have. But you look up the word matter, and it says any substance with mass takes up space by having volume. Okay? And but then they continue to say does not include massless particles. So that's not a matter if it's massless, such as photons or other energy phenomena or waves such as light or heat. Okay, so those are not matter. Okay, so we wonder what they are. What is light? Is it a ghost? What is the category for that? And then you look up the word substance, because that's how they define matter. Matter is any substance. Substance is matter. That's how they define substance. So we have matter is substance and substance is matter. Oh, great. We learned a lot. Anything that has mass and takes up space, same thing as matter. So you can't use the word substance to define the word matter, because matter and substance are synonyms. But then we have the issue of mass. What is mass? Well, it turns out nobody in the last 10,000 years defined the word mass. Here is the definition of mass that you'll find, at least in the Wikipedia. It says, intrinsic property of a body, it was traditionally believed to be related to the quantity of matter in a physical body until the discovery of the atom and particle physics. It was found that different atoms and different elementary particles, theoretically with the same amount of matter, have nonetheless different masses. So, okay, they figured out that same amount of matter, different masses. Okay, great. And it says here, mass in modern physics has multiple definitions which are conceptually distinct. So at no point did they define the word mass. They just said what it ain't. And what it ain't is the quantity of matter. Okay, so what is mass? Well, it says there, one way to distinguish conceptually between at least 7 different aspects of mass, or 7 physical notions that involve the concept of mass. Okay, so they have 7 notions of mass, and I guess they pick the one they want anytime they want to use it. So they have their choice there. Every experiment to date has shown these 7 values to be proportional, in some cases equal. And it says there are a number of ways mass can be measured or operationally defined. Well, we don't care about operationally defined, because that's defining at the end of the presentation. We have to know in advance, before you operationally define it, what you mean by the word mass. That way we can follow your presentation. And what they want to do is they do functional or operational definitions, meaning first let's run a test, and whatever comes out of that, that's the definition of mass for today. Tomorrow we don't know. That's the way they handle it. And so the people who said it really correctly are Wheeler and Taylor here, and they said, nature does not offer us any concept as the amount of matter. History has struck down every proposal to define such a term. Even if we could count number of atoms, or by any other counting method try to evaluate amount of matter, that number would not equal mass. So what did you learn today, son, in school? Well, I learned very little, Father, because nobody can tell me what mass is. They tell me what mass ain't, not what it is. And then they say there's different kinds of masses. Okay, great. What is mass? Before you can tell us the differences between them. And they can't tell you. Of course they can't. And just in case, what was the other word? Volume. Here it is. They don't know what volume is either. Volume is a measure of 3-dimensional space. Well, I didn't know space had 3 dimensions. Space only has 0 dimensions because space is nothing. A cube has 3 dimensions, not space. But see, they always mistake these words. They call it word salad. They don't like to deal with grammar, and they think that's something reserved for English majors or librarians, who knows. And it says the volume of a container is the capacity of the container. Okay. And again, it says capacity is the maximum amount of material that a container can hold. That's in one article in Wikipedia. Another one says an object that sinks displaces an amount of fluid equal to the object's volume. So we got a problem. Either volume is what's inside the container, or volume is what the container pushed aside when it was pushed inside the water. Okay, so here you have the example of a little bolt. It was thrown in water, and that's how much how much water it displaced, and that's known as volume. But these people first say that volume is the same thing as capacity, which is how much the test tube holds as far as water is concerned. So we got a problem. We don't know if volume is on the inside of the test tube or on the outside of the test tube. And they have both. They say it's both. So we don't know what mass is. We don't know what volume is, okay, because they have all these different definitions and different notions. They don't really pinpoint them. They just leave it like that, and they say, well, that's good enough. And they continue. This is the problem. Okay? So this same fellow then comes over and says, form is a three-dimensional geometric figure such as a sphere, cube, cylinder. Okay? Form exists in 3 dimensions with height, width, and depth. Depth? I didn't know depth was a dimension. I mean, where does this poor fellow study? Some monastery or what? And yeah, depth is like breadth are vectors. And the only thing I want to say about breadth here is that, in other languages, they don't have the word for breadth at all. I found out that talking with different people, I finally came to the understanding that they don't have a word for breadth. They sometimes use amplitude. That's the closest they've got, sideways direction. But we're always, when you talk about depth, breadth, or elevation, you're talking about motion. And for this poor fellow to confuse it with a dimension, which is a static concept, whereas vector is a dynamic concept, it means, that he missed important classes at the university. If he went to the university, or more than likely, he got all his information from a monastery. That's probably where he studied. Okay? Yeah, breadth is not breadth or depth are not dimensions or coordinates for that matter. They're vectors. Okay, and this fellow continued. He said, shape is 2-dimensional and form is 3-dimensional, geometric figure. And the question is, where did he get this? A lot of people have the same misconception, And, we look them up and find out what the definition of these words are. Okay, let's find out. It says shape, the quality of a distinct object or body in having an external surface or outline or form or figure. So they're talking about an object or a body, right? And they're just talking about the external surface or outline. Okay, so it could refer to the outline or the external surface. Surface is a 3-dimensional term. Okay, surface refers to a 3-dimensional object. Only 3-dimensional objects have surface. 2-dimensional, planes and so on, they don't have surface. That's not called a surface. They're called planes. Okay, and this quality is found in some object or body, right? And it says its form. Okay, outline, silhouette. And then when you look at form, it says external appearance of a clearly defined area as distinguished from color or material, configuration, a triangular form. And it says the shape of a thing or person, something that gives or determines shape, a mold. So this notion that this fellow has that shape and form are somehow different, is uncalled for, unwarranted, unjustified. He never justified that at all. Okay, and just in case, in different languages, I can only tell you the ones that I either speak or studied or am familiar with, which are the first 7 there. And, in Spanish, Russian, form, German, French, Portuguese, and Italian, essentially they don't have a word shape. They use the word form for everything. There is no difference between shape and form, and as you can see from the definition, shape and form are synonyms. There is no difference between shape and form. Now, some people want to use the word shape to refer to a 2D and form to refer to 3D. That's their personal prerogative, but there's nothing in the definitions that shows that. Okay, and then you can see other languages there, the same thing. They only have the word form in almost every language. Okay, so there is no such word as shape in other languages. Okay, so they don't make a distinction between shape and form, one being 2D and the other one 3D. They just call form to everything. That's the first issue. Okay, so here you have a 3D cube. Well, is it? Looks like a 2D cube to me because it's on a flat platform, flat background. Okay, so what I'm staring at is really a 2D cube. There is no 3D. Now, it's the mind that gives projection, depth, or length, latitude, or whatever you want to call it. You have something here where you can see a projection, right? Well, but it's because the mind does that. What's coming out of the screen is not 3D. What's coming out of the screen is objectively 2D. And it's the mind that fools you into believing that you're staring at something with projection. So let's remove the stuff that's bothering you that makes you think that this is a 3D object. Here it is, okay? That's what you were staring at. Some of those lines were bothering you, okay? They were making you mistake what was coming out of screen objectively, which was 2D, for a 3D object simply because we put these lines on there, okay? So it's the mind that does that, not what's coming out of the screen. Objectively is what comes out of the screen. Subjectively is what you have in your mind, okay? And so the first thing I want to mention is that, the reason we say object is that which has shape is because even if it were 3D, even if you use form and accept it as 3D, the 3D includes the 2D. So by using the 2D shape, as you want to call it, you're including all objects in the universe. Includes anything that's 2D and 3D, and there's no 0D, 1D, or 4D or above. So by putting 2D, you include every object in the universe. Now, if you want to specify and say, well, that's a 3D object and this is a 2D object, no problem. Yeah, you can specify that later. But object, that which has shape. And shape, if it's 2D in your mind, no problem. It still covers the 3D because 3D objects have shape also. Okay, imagine here's a lady and she's trying to give a presentation and she says, and this is Schrodinger's cat before he died. Okay, and so the question here is you say, oh, you can't present that in physics because you're presenting a 2D object. That's not a 3D cat, that's a 2D cat. And so if a person gives a presentation, they are not able to say this cat is an object, is a thing. You say, no, it's not a thing because it's 2D. It has shape, but it doesn't have form. Well, obviously, you're representing a cat, and just like you did with a cube, you're supposed to imagine, right, see what's not on the screen. What's on the screen is 2D, but your mind already understands, or is supposed to understand, that that cat is 3D, okay? And the reason it's 2D only because you had to bring a picture of the cat, snapshot you took of your own cat maybe, you brought that to the presentation, say, look, this is a cat. Okay, so if we were to differentiate, we would not be able to give presentations using 2D images because, oh, that's not physics. No, because you're making a representation of something else. I mean, I can show you this and say this is a rope, and but what do you see? You see 2D because you've got a screen that's pointing that out to you as a 2D object. Okay, it's the mind that said, well, I know that's 3D, partly because Bill is behind the rope, okay? But I can point to a picture of a rope and say, look, rope. Are you going to think that that's 2D and that's not acceptable in science or in physics because it's 2D, because it's just an image, it's a representation of a rope? So obviously, the word shape is just fine, even if in your mind it's 2D, which it ain't the world over. Everybody uses the word form, and it's the same thing as shape. Shape is just an English word that means form. Okay, I hope that's taken care of. And this person had another issue, and he said, material sphere form has the shape of a circle. A magnetic field has the shape of a circle. No, a magnetic field has no shape whatsoever. And let me prove it to you. Proof. Here's evidence. Okay? Authority. Okay, we go to the Physics Stack Exchange, a prominent site for so-called physics, mathematical physics actually. And what do they say? They say, look, all fields are really infinite. Okay? The magnetic field decreases with the square of the distance. Magnetic field, field, decreases with the square of the distance. It never ends. You move away from a current that generates the field. The same goes for a static magnet, etc., and they put the little infinity sign there. So where does the field end? At infinity. It never ends. Okay? And how about in fact it says, the magnetic field in the same way as an electric dipole field will vanish where? At infinity. And how about the gravity field, gravitational field? Well, the same thing. Gravity has infinite range. The force of gravity decreases 1 over r squared, thus slow enough for it to be felt, etc., on the other side of the universe. So how big is the gravitational field? How big is a electric field? How big is a magnetic field? They are infinite, conceptually infinite. They stretch out forever. Okay, so this notion that you have that a field, any field, has shape, you forgot to factor the definition of the word field. All fields are infinite. And whatever is infinite has no shape, no form. Okay, because you cannot see the end of it. You cannot see the edges of it. Okay, so please point to a field that has shape. And whatever you point to, I'm going to put some more of those numbers there and show you that it extends forever in any direction that you wish to see it. It's just that you do not realize that your field extends forever. And so something that extends forever does not have shape. And until you understand that, well, you still haven't taken kindergarten classes in physics. Okay? Okay. Let's move on to the subject matter today, which is the conscious universe. Conscious universe. Is the universe conscious? Does the universe think? Is universe like God, intelligent design, fell there with a brain that had a purpose for us, for the universe, for everything? Maybe he's playing a little toy game in heaven, a little toy soldier. He says, I'm going to entertain myself. I'm going to create some humans and some animals and some earth and whatever, and I'm going to watch what happens, and control it, right? Because you got to control. You don't want your experiment to get out of hand, right? Anyways, there are different notions of what this universe is, and we saw a couple of them last week. Here's the notion that we presented the other day, the electricians, the electric universe primarily, but there are others as well. And they believe that the universe consists of all these things, plasma and electric currents, and that everything is done with magnetism and so on. So they have these notions. They like to tinker with gadgets such as oscilloscopes and ammeters, voltmeters, and so on. Great. They think the sun is just a ball of plasma on the outside, and that's where the heat is generated. It's not generated in the center of the sun. Okay. Then you have on the other side mathematical physics, primarily the relatives when it comes to the cosmos, the big world, the world of the big. Okay, and they believe in black holes and wormholes and the W maps and the space-time and dark matter and all this good stuff. So this is their world, and you can see that they don't match. That's why they don't like each other. Okay. The folks on the right, the relativists, they are more powerful. They have control of the strings of information, and so they press the other guys down with their thumb. They say, I'm going to squash you because I have the power. Okay? Okay, so what is this universe like for all these people? In fact, it doesn't matter whether it's the electricians or the etherists or the establishment. This is what they propose. Whether they know it or not, this is the only thing that's ever been proposed in the last 10,000 years. Okay, here it is. Particles. This is all they understand. This is all they ever done. It's called the ether in one religion. Another religion calls it the false vacuum. Another religion calls it space-time. It's all the same thing. Okay? No one's ever done anything different than this. Particles, many particles. This is the only proposal we ever had on the table. Okay? So this is our starting point. And so there are other people that say, well, there's a little more than that, than particles, than, coordinates and dimensions and vectors, values. There's something else that is not really measurable. It's called conscience, or being consciousness. Okay? That's what it is. And this goes, a long ways back in history. Here you had one of the famous guys who proposed this. His name was the Buddha, Gautama, right? And the Buddha taught that everything is connected and that everything is constantly changing. Now that's a little different than the particles you just saw, because the particles, they're not connected. And here these people are saying everything is connected. Okay, so are they talking physics or are they talking poetry? What are they talking here? And it says these fundamental observations of the world are shared by ecology and evolution. And that's the site there. You can look it up. Another site, a fellow writes a little paper, says there can be no first cause and no creation ex nihilo of the universe as in the Big Bang Theory. Since the universe has neither beginning nor end, the only universe compatible with Buddhism is a cyclic one. Okay? According to Buddhism, the exquisitely precise fine-tuning of the universe for the emergence of life and consciousness as expressed in the anthropic principle is not due to a creative principle, but to the interdependence of matter with flows of what? Consciousness. We have the flow of consciousness, the two having coexisted for all times. So consciousness not only exists, but consciousness flows. Oh my God, I'm wondering what this guy is talking about. Back to word salad. Let's do a little word salad that offends these people so much. Here it is. Let's look up the definition of consciousness. What the hell are they talking about? Consciousness, it says awareness. Went some other words after that, but essentially awareness. What is awareness? A concept about knowing, perceiving, and being cognizant of events. And that's more or less the notion that everybody has of consciousness. So how can a concept exist? In what way does it exist? And how does a concept flow? Okay, so we got a problem there, because this Buddhist says that a concept not only exists but flows. And that's a little different than the universe created by the mathematicians, which is a world of particles where who knows how they interact, because, they're not connected, they're not touching each other. All the particles are discrete. Point in space-time, that's an event. And this event is separate from this other event. And anyways, you can't connect events because they're concepts. So how are you going to connect them? And so we have these problems. They put concepts in there and they say, well, this concept's over here, this concept's over here. And are they connected? No, they're all independent. But then they say this concept, meaning a particle, can affect that concept, another particle, through entanglement. So how does it affect it? Please explain the mechanism. And that's where they put more concepts in between, and they say, well, this concept affects that concept through another concept. So we're full of concepts and we don't understand squat because we can't visualize the mechanism. That's the issue. Okay, so here's one person who tries to explain it in Quora, says, all points of space and time are connected. So they're connected. I guess they're not connected by consciousness, like in the case of Buddhism. It means that everything in the universe is connected in some way, even when they are separated by massive distances or vast amounts of time. Okay, connected how? What connects them? They just say this, they're connected. What do you mean by that? I mean, connected what? When you talk about a connection, especially you're talking about physics here, you better have a physical entity mediating or serving as a mediator. And these people say they're connected. Take it or leave it. Like it or not. I'm going to shove it down your throat. They're connected. That's just a statement. They haven't justified it. This connection is often referred to as the fabric of space-time. Space-time is a concept, not a fabric. Okay, fabric is, this is a fabric. My clothes, that's a fabric, what it's made out of. But space-time is not a fabric. Space-time is known as a concept. Time specifically, hopefully you'll understand that time is a concept. You cannot say that it's a fabric, that it's a thing, and so you cannot say that two particles are connected, or two particles first, two corpuscles are connected by time. That's not a connection, okay? You might say one influences the other, and you would have to explain how, but you cannot say they're connected. Connected is a physical term. Okay, but see, they slide these words, they sneak them into physics, and they're connected. Well, show me the connection. You know, if they're connected, what is it? A chain that connects them? Or is it a rope? Is it a string, cable? You know, how are they connected? Wire? You know, when we move, we can feel the space-time curvature around us. Oh yeah, how many drinks did you have? Bartender, I want whatever he had. So you can move, you can feel the space-time. I feel the air, but not space-time. This means that events that happen in one part of the universe can have an effect on events that happen in another part of the universe, even if they are separated by billions of light years. Okay, but you got to tell us how they're connected, how one affects the other physically. That's what we need to understand. And here another fellow follows up and says, all points in space and time are connected. Means that you can draw a line between any two such points. No, draw a line is not connected. You still have, because until you draw your infinite line, you know, so far we have no connection until you finish your line. And since a line is made of infinite points, I guess it's like Achilles and a tortoise, you know, never catch up. So you cannot say all points in time mean that that are connected, means that you draw a line between them. That's not connected. That's math. That's not connection. That's just like, that's just the math. Exactly. Not all points have the same kind of physical connection. And again, it's not a physical connection that you have been talking about. For instance, there are trajectories in space-time that are not possible. What does trajectory have to do with connection? So you cannot always get from one point to another by obeying the laws of physics. Okay, I don't know what he's talking about there. There is a metaphysical meaning about the spiritual connectedness of everything. Yeah, they talk about spiritual connectedness, not about physical connectedness, and they can constantly confuse one with the other. They treat consciousness as a physical object, as if it were a string or something. They say, we're connected. We're connected by what? By consciousness. What do you mean by consciousness? Yeah, it means that we all have these, I guess, telepathy? I don't know what they're really referring to. What do you mean we're connected by consciousness? What kind of nonsense is that in physics? I mean, if you want to talk poetry over there, you know, in a class, no problem. Talk about it, or religion, you know, no problem. But if you're going to come into physics and talk about connectedness, then you got a problem, because, no, we're not connected by consciousness. You can be connected by a rope, by a wire, by a cable, but not by consciousness. There's no telepathy or telekinesis in physics. Okay? No such monster. Okay, so here's another fellow. He's got a site, and he says there is a deeper connection. They all talk about connection, huh? That unites all things in the universe. All things, all objects, right? And it can be observed in various realms, from the physical to the spiritual. Okay, let's look at the physical. I don't care about the spiritual. And he says the interconnectedness of all things is a principle that suggests that everything in the universe is interconnected and interdependent. By the way, this is a professional site where the guy has a quantum equation, and that's what he sells. He's trying to convince people to buy stuff that he can fix, or he can solve problems with his quantum equation. And he says, imagine a spider's web, with each strand representing a different aspect of the universe. Each strand is connected to every other strand, and the actions of one strand affect the entire web. Okay, so far so good. I like this, because it looks like my theory here. This is similar to how everything in the universe is connected and interdependent. Okay, no problem. I can understand that. He's talking about a spider's web, so he's got all these little threads, right? And all these strands are connected to every other strand, etc. Okay, we all understand this. No problem. If he can draw that, or at least we can picture what he's saying. But that's not what he's talking about. He's talking about something else. He says the principles of quantum mechanics and the theory of general relativity demonstrate that particles and forces are interconnected at the subatomic level. particles and forces? The particles are wave function collapses and vibrations of fields, both concepts. And forces are concepts as well. So how do you connect concepts with concepts? They're connected by what? Okay, so he's already got a problem there because he's not making any sense if he's going to bring quantum into this. I mean, he was doing fine when he was talking about a spider's web, but as soon as he talks about quantum particles, which aren't particles, and forces, we cannot talk about interconnectivity because connectivity is a physical term, and he's not talking about physical, he's talking about concepts. This interconnectedness is not only limited to the physical realm, but also in the emotional, psychological, and spiritual realms. Suddenly he goes on a tangent, right? He's talking about emotions, thoughts, and actions, right? And he says this interconnectedness can be observed in the realm of consciousness. Oh my God, one of those, huh? Many spiritual traditions and philosophical teachings propose that we are all connected in a what? Deeper sense. Okay, what's this deeper sense? Hopefully something physical, right? That our individual consciousness is part of a larger collective consciousness. This idea suggests that everything in the universe is interconnected in a way that is beyond the physical. And again, you can see they use the word interconnected with consciousness and the spiritual. They're talking about feelings, thoughts, actions, you know? And so now they're connecting verbs. And this is how they slide these words in there. And not only these people do it, other people do it as well, you know, people who are into this consciousness stuff. You know, I detest the word consciousness, especially when they bring it into physics. I never want to hear that word. Never. Every time I hear the word consciousness or conscious, it drives me up the walls because I know I'm talking to a, what do you call it, idiot? Yeah. Okay, so here's one of the famous guys who does consciousness and introduces it into physics or mathematical physics, okay? His name is Nassim Haramein, and he said the world is profoundly connected. Okay, he calls it the connected universe. He's got a video on that. Says our planets, stars, and galaxies account for only 4.9% matter of the universe. He got that from the establishment, okay? So he's vouching for the establishment here. He's going to take a detour trying to say that he discovered something new, right? So what makes up the rest of the universe? Okay, and he says space. Space is not empty. Space-time at the quantum level is fluctuating with an intense energy level, full of dynamic energy components. So we have space, or space-time, and it's full of energy, whatever energy is. And what is energy? Energy is an undefined word. To this day, they aren't able to define it. Or as Mr. Richard Feynman said, he said, we have no idea what energy is. Yeah, because energy is not a thing. It's not a what. Okay, there's no such thing called energy. Energy is a mathematical concept, so to say, what is energy, or you point to energy, you can't do that. You can't draw a picture of energy, because it's a concept, any more than you can draw love or intelligence. Everything is connected through this energy. So what does he propose as a connection? He proposes this mathematical concept called energy. That's in the space that actually it is the space that creates matter. And so he says space creates matter and energy is within this space, and it's this energy that connects us. Great. We understood quite a bit. Oh my God. I wonder what these people drink. You know, I'd like to have a shot of that. I mean, I'm just a regular guy. I just drink beer and wine. These guys drink really hard liquor here, or maybe shoot up. I don't know. Okay, so how does Haramein continue? He's got by the way, an organization that sells some snake oil out there, and that's how he makes his money. So we often hear the sentence or this concept, everything is connected. It's all one. But how is that true? Space is what's connecting everything. And space is the great organizer. Space is the thing that connects all things. Okay, so space is a thing. It's all this energy in there, and it connects everything. Okay, but I want you to see how he slowly drifts into where he wants to take you, to consciousness. Okay, if we look at all the little fluctuations of the vacuum, all the rest of the mass in the universe is represented what? Holographically. I wonder if he got that. By the vacuum fluctuation inside one little proton. Okay, we're talking about vacuum fluctuations inside a proton. I guess he's been there. He saw it there. So that one little proton is connected to all other protons in the universe. We don't disagree there, but what is he connecting it with? He's connecting it with energy. And where's this energy? It's inside the space, and space is what creates matter. This is his notion, okay? And he says our universe is holographic in nature. Why does he say that? Well, because everybody in string theory is studying holography now. They're into holograms and the holographic principle. And so he knows that that's popular. So he's trying to get the right words in there so that he can sell his snake oil. That's what it's all about, okay? So here he says how he turns this energy into fields and into feelings. He's going to drift into consciousness or out of consciousness, I guess. I don't know. There's a flow of the universe around you and a flow of the energy of the universe inside you. Okay, so now we have this flow of energy. It's going around the universe and also inside you. This dynamic energy of the universe is constantly flowing through all of space inside each one of our atoms, connecting us all. So we have this energy that's constantly flowing through every atom, and that's what's connecting you to me. Okay, so I don't know what kind of connections he's talking about. He's talking about physical connections. How am I connected to you? Through this energy, which is a concept. And he says you can literally feel the force of the universe inside you. Okay, I don't feel the force. Sometimes I feel the alcohol, but not the force. And flowing through you, connecting you to everything. Physical objects are not in space, but these objects are spatially extended as what? As fields. So you can see how he's using all this verbiage. He's just throwing words in there that have no meaning. And he says, look, it's space that creates matter. And there's all this energy, whatever that is, inside space. And that's what's flowing through every atom. And because it's flowing through every atom, these rivers of energy, these fields, that's what's connecting us. How is it connecting? I mean, can I untie myself from you? Can I cut this energy and, with a scissor or something and, have my freedom from you so I'm not connected to you? Okay, so this is the way he finishes. He starts out by talking physics, quantum, general relativity, space-time, energy, uses these fancy words, and then he goes in there and says, this is how he ends his presentation. He says, kindness and love and fear and sadness and joy and anger and stress. So this is what he ends his presentation. So what is he selling? He's selling all this consciousness based on energy belonging to so-called physics, actually mathematical physics, and the consciousness belonging to his religion. I don't know if he's trying to win a Templeton Prize, which is a prize given to those who try to merge so-called science or mathematical physics actually with religion, with the spiritual world. They have this conscious universe in the back of their minds. And so, the question is, what are these people talking about? What have you learned from them? They're just using mystical words. They're selling you snake oil, the snake oil peddler. He's saying, buy my elixir, it's good for you. That's all they're doing. They're just using words. What are they selling you? Well, what's the bottom line? What have we understood about the universe with all these people talking about the flow of energy through atoms, this energy that's throughout the universe, whatever it is, because it fills space. So hopefully it's a thing. What is it, smoke? Is it a gas? Well, what is this energy thingy? And so it's this energy that's flowing, and if it's flowing, how can it connect us? And suddenly, that energy morphed into feelings and anger and who knows what. And suddenly you have consciousness flowing in there right behind it. So that's how they introduce it in there. Okay, so here are the two universes that we propose. We have the mathematical physics universe, bunch of particles, which is what I started the presentation here today with. And that's the universe everybody has. And everybody proposes. No one has ever proposed anything different. Everybody says just particles. And even those who propose the ether and they talk about blobs, they don't realize they're talking about what the blob is made of, which is particles. And that's why it's fluid, that's why it's malleable, because it's made of discrete entities called particles, corpuscles or whatever. So this is the mathematical physics world. How did Stephen Hawking define it? He says, an event is a point in space-time. What is a point? It's a dot. What is a dot? It's a vibration of a field, a local vibrational field. Everything's made of field. What is a field? Well, it stretches infinitely. There's no end to it, and that's how they leave the room. So they say, oh, by the way, we don't understand anything, but Father Universe, he doesn't speak our language anyways. So we cannot hope to understand him. He doesn't understand us. And what do we propose instead? Well, we have this parallel universe that is different than the one of discrete particles. We're saying all atoms are physically interconnected. They're connected to each other. Any atom, hydrogen atom, when I talk about atom, is connected to any other hydrogen atom in the universe. And bigger atoms are simply, or bigger elements, you can say, more massive elements such as iron, whatever, lead, they are made of more hydrogen atoms. So every hydrogen atom that forms an iron atom has a rope connected to any other hydrogen atom in the universe. Okay, that's a proposal, that's the assumption, it's known as a hypothesis, so that you know our starting point, that's how we start our presentation, and then based on that we explain light, gravity, magnetism, electricity, and so on, workings of the atom. Okay, so all I can say is latecomer came in there, put the comment today, so I didn't have really time to answer him in a more complete way, but he asked, what does knot theory have to do with the rope model? And the answer is absolutely nothing. If you look up the knot theory over there in the Wikipedia, that's what you find. It's a mathematical concept, okay? And they talk about knots. Like if you take any string, you tie it in knots, you get all these different shapes, and that's what they mathematize, and they try to put equations on how to build this. In other words, they build an equation that can simulate each one of those knots. Okay? That's all it is. It's got absolutely nothing to do with the rope model. The rope model is a physical model. And what is a physical model? Well, we're saying we have two atoms, hydrogen atoms, and they're connected by a rope. Very simple. Think of a dumbbell, not me. Think of a dumbbell, and that's what the rope model is. You have a rope that connects two balls. What are the balls? Two hydrogen atoms. And they're made out of the same threads as the rope. And the atoms expand and contract, and they torque the rope. Baby stuff, kindergarten stuff. Anybody can understand it. The universe is a very simple world, simple universe. It's the mathematicians who made it complicated, and it's the fact that they use math to try to describe it that is very complicated, because if you've taken math at the college level, you know what I'm talking about. It's very complex. Okay, you take calculus, you take linear algebra, and so on. It's very, very sophisticated math. Okay, and but that's just to describe. That doesn't explain anything. To explain, you need physical objects, and that's when you go back to kindergarten and play with blocks. That's how simple it is. Two balls connected by a rope. The balls expand and contract. These two balloons expand and contract. They torque the rope. That's light, and when you have many atoms, what you have is gravity. Kindergarten stuff for anybody. We'll see you next week with that. Bye-bye.